Okay, for Chapter 8.2, Day 2, we're going to delve more into the trigonometric ratios in right triangles. Again, only right triangles in Chapter 8.2. You'll notice the objectives for today. We're going to find sine, cosine, and tangent of a 30, 45, and 60 degree angle. If you recall from yesterday's video, these should be unique values. So we're going to focus on a specific triangle of each type that has these angle measures in it. We're going to find that no matter how big the sides are, we're going to get the same answers every time for those. We're going to solve a word problem using a right triangle trigonometry, which will also involve finding a missing side, just a use of basic right triangle trigonometry. And then we're going to be finding the measures of acute angles in a triangle given some sides. So if we know angle measures and a side measure, we can find other side measures. If we know a couple side measures, we can find angle measures. That's basically the main use of right triangle trigonometry, is to find missing sides and or angles in right triangles. For example 4, what I've got written here, basically if we had done 8.1 Day 2, we would have gone through this. Since the main idea of 8.1 Day 2 was just to get this information that's on this one slide here, I didn't feel the need to actually waste a day of instruction just showing you these two pictures. So you guys should copy these into your notes. I'll take a moment here, pause the video, and I'll start back up in a moment. Okay, so this is a 45, 45, 90 right triangle. You can see this is a 90 degree angle. 45 and 45 adds up to 90 for a total of 180. This is also sometimes referred to as an isosceles right triangle. As you can see, the two equal angles are 45. The sides opposite are both the same measure, 1 and 1. The hypotenuse here is square root of 2. If I did the Pythagorean theorem, 1 squared plus 1 squared is equal to the hypotenuse squared. That means 2 is equal to hypotenuse squared, so that means that the hypotenuse equals the square root of 2. That's where the square root of 2 comes from. But basically, if you just recall this would be something you want to commit to memory, this triangle. When you have 45s here, these are the same. This is the square root of 2 times bigger than this number. So this is really 1 times the square root of 2. If this was a 4 and this was a 4, this would be 4 times the square root of 2. All right. So, but typically we start with the base level of 1 square root of 2. Over here we have a 30, 60, 90 right triangle. And this one is, obviously this is isosceles. This one you just have to kind of believe. I promise the numbers are correct. But you'll notice that the smallest measure angle is 30. The smallest side is 1. 60 is the one in the middle. Square root of 3 is about 1.7 in between 1 and 2. And 90 is the biggest, 2 is the biggest. 1, 2, square root of 3. And again, if you do go based on size, smallest angle, smallest side opposite, middle angle, middle size side opposite, biggest angle, biggest side opposite. Once again, Pythagorean theorem, if we tried it out, 1 squared is 1, square root of 3 squared is 3, 4 equals h squared, h equals 2. You can see there that it works with those numbers. And again, I promise you those are the right numbers for 30, 60, 90. Okay, so they want me to find the sine, cosine, and tangent for 30, 45, and 60. So obviously 45, 45 doesn't matter which one I go with. I'm just going to pick this one down here. Again, just like we did with the videos from day 1, one of the acute angles is more important than the other. There's the one I'm going with. If I go across the triangle, that side's opposite. If I go across from the right angle, that side's the hypotenuse, which means the third side is the adjacent. Okay. So the angle measure is 45 degrees, so you can see here that the sine of 45 degrees equals opposite 1. Oh, I forgot to write my SOHCAHTOA down. So again, just from yesterday, so from day 1, S for sine, so sine of the angle equals fraction bar, opposite on top, which is 1, over hypotenuse, which is the square root of 2. Just like we saw in example 3a from day 1, we have a square root in the denominator. We need to fix that. We simply multiply top and bottom by the square root of 2. That gets me the sine of 45 degrees equals the square root of 2. 1 times the square root of 2 is the square root of 2 on top. And the square root of 2 times the square root of 2 on the bottom is just 2. So the square root of 2 over 2 is the sine of 45. The cosine of 45 degrees, doing cosine, I go to CAH, C for cosine of 45 equals fraction bar. Adjacent on top, adjacent is 1. Hypotenuse on the bottom, hypotenuse is the square root of 2. Notice it's exactly the same, 1 over the square root of 2. So that'll simplify the same way. No need to go through the math to do that again. cosine of 45 is the square root of 2 over 2. And then tangent of 45, we'll put that up here. So tangent's TOA. There's my 45-degree angle. Tangent's opposite, which is 1, over adjacent, which is 1. And that simplifies to 1. So sine of 45 is the square root of 2 over 2. Cosine 45 is the square root of 2 over 2. Tangent 45 equals 1. If we move on to the 30-degree angle. Okay, so a 30-degree angle, I'm going to identify the opposite side. So this is the acute angle I care about. I go across the triangle, that's opposite. I go across from the right angle, that's hypotenuse. And the other side would have to be the adjacent. So I need sine, cosine, and tangent for this. So sine of 30 equals something. Sine is opposite, which is 1, over hypotenuse, which is 2. So sine of 30 is equal to 1/2. I have to write the correct number down. The cosine of 30, cosine is defined as adjacent, which is the square root of 3, over the hypotenuse, which is 2. That has a square root in the top, which is just fine, so both those answers are perfect the way they are. And then finally, tangent of 30 degrees equals opposite, which is 1, over adjacent, which is the square root of 3. Now you'll see this one, square root in the denominator, that is no good, so we're going to have to fix that. I'm going to multiply by the square root of 3 on the bottom and the square root of 3 on top. And that becomes then tangent of 30 equals 1 times the square root of 3 on top, square root of 3 times square root of 3 on the bottom. This is the better answer. Okay, so I don't want to use this, I want to use that. This is the right answer for cosine of 30, that's the right answer for sine of 30. And finally, if we're dealing with a 60-degree angle, I'm going to erase all the green here because I'm going to have to use the same triangle. Now the acute angle I care about is the 60-degree angle, so I'm going to go across the triangle to find my opposite. I'm going to go across from the right angle to get my hypotenuse. And that means these two are identified, so the third side must be this side, the adjacent. I'm going to sneak it in over here, I think. I just grab all this. Make it a little smaller. There we go. All right, so sine of 60 degrees equals fraction bar. So sine is still opposite. Now for the 60-degree angle, the square root of 3 is opposite. Over hypotenuse, and for this the hypotenuse is still 2. So sine of 60 equals the square root of 3 over 2. Cosine of 60 degrees equals fraction bar. Cosine is adjacent side, which is 1, over hypotenuse, which is 2. So cosine of 60 is 1/2. And then tangent of 60 degrees equals fraction bar. Tangent's opposite, which here is the square root of 3, over adjacent, which is 1. So square root of 3 over 1, also known as the square root of 3. If you want to leave it over 1, it doesn't hurt anything. Notice that the sine of 30, the cosine of 60 are the same. Cosine of 30, sine of 60 are the same. Because all that really happened was the opposite and adjacent got flip-flopped. So that happens when you deal with complementary angles. But again, for these specific angle measures, 30, 60, 90, these are well-known sine, cosine value, and tangent values. So these triangles allow you to find them out, but over time you're going to probably commit these to memory. They get used often enough.